Good day, guys. Today we are going to deal with equations of motions, vertical projectiles. But before we get to the content, please do not forget to subscribe, like the video if you enjoy the content, and more specific, please share the content with your friends, those who really need the sessions. Okay, guys. Today on our topic vertical projectiles, I'm going to divide the topics according to like cases. Okay, so when we deal with vertical projectile, there are certain terminologies that you need to understand, like the term free fall. For example, what is a free fall? When we talk about a free fall, we talk about a motion of an object under the influence of force of gravity alone. Okay, so that is your free fall, the definition of free fall. And you must get to understand certain terms, like what does it mean when they say an object is projected. When an object is projected, you just have to know that it's either pushed or maybe kicked, something like that. It is given an initial velocity, you understand? Okay, and you also need to understand, like, how does or what does the word released mean. Is a released mean, sorry, okay, the word released, I need a rubber here, an eraser. Okay, yes, you have to understand what the word released mean. When we say an object is released, we actually give you an initial velocity as 0, and when we talk about an h max, which is the maximum height of an object, the velocity there is also equals to 0. Velocity of maximum height will always be equals to 0. Why? Because that is the turning point of our object. Okay, so some of the definitions or terminologies, I'm going to explain them throughout the session. Okay, guys, stay tuned and please participate. When I solve a problem, after giving you the problem, please, you just pause the video, work it out yourself, and then unpause it and check how I solve the problem. Okay, let me clear this. So our topic will be vertical projectiles. Fine. Now let's check our case 1. Case 1. You may be given let's assume this is the ground. This is our ground. Yeah, this will be our ground. Then an object is thrown vertically upwards. This is a ball thrown vertically upwards at a certain speed, v initial. Okay, so how will you illustrate this kind of a motion? So I'm going to draw something like a position time graph, something related to it. So okay, let me do this. My drawing is bad. Something like this, something like that. Okay, so we are going to have this. Okay, yes. So as you can see, this shape is slightly symmetrical about the green dots that I just drew. Now, if an object is kicked at a certain velocity, like initial velocity vi, when the object goes up and comes back at the very same point, you are going to have a negative vi, the same velocity but in a different direction, because now the ball is going downwards. Okay, this point here will be showing us the maximum height. This is H max here. Maximum height, this is where we have our VF, which is equals to 0, and the time it takes for the object to reach maximum height will be the time it takes for the object to move, like this T, this will be T, and then this will be 2T. So the time it takes from this point to this point is equivalent to the time it takes to move from this point to the other point. So when you kick a ball and it reaches maximum height, because the ball will return back to the original position. So when you kick the ball, yes, then the ball reaches the maximum height. It will take this very same time taken for it to reach the ground. So with this theory, it's going to help you to calculate some of the unknown constants. And always, under our vertical projectile, always G is equals to 9,8 meters per square second downwards. Always the value of G goes downwards. It never changes direction. Okay, so in your grade 12 you are given the courtesy of choosing your direction unless if the examiner states otherwise. Okay, now this is our case 1 scenario. Now let us look at case 2. Okay, looking at our case 2 scenario, we might have something like, okay, assume that you have a building. You have a building and there's someone waiting on top of the building here, sitting here and projecting a ball at the speed of vi. Okay, so this shall be our case 2. Now let's see, like, if we avoid the air frictional force, what's gonna happen to the motion of our object? So obviously, due to gravity, the speed of this ball will decrease. It will decrease until it reaches a maximum height. So the motion of the ball will be like this until it reaches maximum. Then now it comes back to the very same point, but that's not the end. It also goes back down. Okay, so now let's check at our time taken. If this is the symmetry, or where we can cut the graph into two, we can like check the time taken for it to reach the maximum height, of which, if this is t, this is going to be 1 over t for it to move from here to maximum height, then from here to here. I mean 1 over 2t, not 1 over t. Okay, so this, the time taken from here to the maximum height will be equal to the time taken from the maximum height to the ground. Not to the ground, exactly ground, but to the very same point where the object was projected. So the speed here will be negative vi. Okay, so this part over here, this part inside the box over here, is identical to case 1. Okay, now above that, from here the speed of the object increase. The speed of the object increase, but in the negative direction. So VF here will be very much greater than this VI, And remember, step 1, choose your direction. Always choose direction. This is the step 1 of solving your equations of motion or your vertical projectile. And under step 2, write your data, the given information. For example, if you choose upwards as positive, you know that 9,8 will be negative because it's going downwards. Okay, then if a maximum height is given, you write it down. If time is given, you write it down. Then whatever that you don't have, you put it in question marks. Then now you can now look at the question. What does the question ask from you? So if the question is asking for time taken, then you know which equations to choose. Okay, so looking at these equations, most of them, they have like 4 variables. You need to have at least 3 of those variables for you to solve. So go for the equation that has the most values given to solve for the unknown. Okay, fine. So now we are going to check on our last case. So basically the last case is the reverse process of the first case, of the second case I mean. So now assume a person is here. This person gets off the building and now they come to be here, and they project this ball upwards with the speed of vi. Okay, so this shall be our case 3. Then the ball goes up, but when the ball returns back, someone catches it. Okay, so the final velocity will be less than vi because the ball won't accelerate enough for it to return to its original position. Okay, the time taken for the ball to reach maximum height will be greater than the time taken for the ball from the maximum height to the point where someone caught it. Okay, so remember, you must know the difference between projected, released, kicked, and the word maximum height. When they say the ball is under free fall, what is the acceleration? You understand? So you need to know those terminologies because they are giving you certain values, the ones that they are not given in numerical values on your scenario or on your question. Now let's go back, let's go to examples and to see how can we apply the theory given above. Okay, this will be our example. We have a 40-meter high building. This is a building with a height of 40 meters. 40 meters. And we have a ball here. Projected upward at an initial velocity of 10 meters per second. Okay, and the question says take the ground as your point of reference. So this is our ground, okay, and this is point A. This is A. Let me see. And yes, and of course you must ignore the effects of air frictional force. Now the first question is define the term free fall. Okay, so we have defined the term free fall that it is the motion of an object under the influence of gravitational force alone. Okay, now calculate the maximum height above the ground reached by stone A. Okay, so now the stone is thrown upwards and we have to calculate uh, the maximum height reached by stone A. Okay, now which direction do we choose as positive? They haven't chosen any direction for us, so I'm gonna choose upwards as positive. Okay, it's fine. I'm gonna choose upwards as my positive. Now let's check my data. What is given? I know that I have minus 9,8 meters per second, so that's G. I have G, I have VF, which is equals to 0. Reason, maximum height. I also, this is VF, this is VI, is equals to 10. I have 3 already. So, and yes, I'm looking for the fourth one, which is my maximum height. Okay, so which equation of motion does it contain? These three contain gravitational acceleration, it contains final velocity, initial velocity, and it must also contain your height. So make sure that the equation that you choose doesn't have time, because there's no way we are given time. Okay, so we have this equation of Vf squared is equals to Vi squared plus 2g delta y. It's delta y because we are dealing with our vertical motion, and you are going to see the difference there when we deal with our two-dimensional kinematic equations. Then yes, it's the same as vertical projectiles, but now you have to include the 2D, the horizontal motion. Okay, fine. Now let's rewrite this equation in the form of y. So delta y is equals to Vf squared, we bring Vi the other side, minus Vi squared, then we divide by 2g. Okay, now do the substitution. Vf squared, V final is 0, so we are going to have 0 minus Vi, it's 10 squared divided by 2 into negative 9,8. Okay, so this is 100 divided by, it's 100 divided by, it's negative 100 divided by 19,6. Okay, so now 100, okay, you can see our 100 is negative and our 19.6 is also negative, so the two negative signs will cancel each other. Then we are going to have 5,10 meters as our maximum height from here to there, but the question says above the ground. Okay, so Vmax or Hmax, H is equals to 40, the height of the building over here, it's 40 meters, plus 5,1 meters from here to the maximum height. Then our final answer is 45,1 meters. This is above the ground. Okay, okay, now second question, write down the magnitude and direction of the acceleration of stone A at this maximum height. So acceleration A, of which is also equals to G, which is equals to minus 9,8 meters per squared second. Okay, So when you include negative, because I've stated that my upward motion is positive, it shows the direction. Or you can write it as g is equals to 9,8 meters per square second downwards. Remember what I said, guys. I said gravity always the direction of gravity goes downwards. Okay, so I think this is an easy question. They were just deciding to give away marks. So just to disturb the session, if you want a private tutor for mathematics, physics, just contact me on 0799454660. You can WhatsApp me there, or alternatively get me on this email, tato m505@gmail.com. So this is how you can get hold of me, and we can talk about the way forward. Okay, I can also include some of the engineering modules, like the electrical circuits, some of the electronic circuits, engineering mathematics, engineering science, chemistry, and so forth. Just contact me. Okay, now let us proceed with the second session. So now a second ball is introduced. Okay, so we have stone B that is dropped from rest from the edge of the roof X seconds after stone A was thrown upwards. Okay, so now we have stone B. This is stone A, this is stone B. So stone B was dropped. Dropped is the same as released. So it goes downwards. V initial equals to 0. Okay? The only thing that's gonna cause this object to move is the gravitational acceleration. Okay. So so this is the scenario that we are given, that stone B is dropped from rest from the edge of the roof X seconds after stone A was thrown upwards. Okay, now stone A passes stone B when the two stones are 29.74 meters above the ground. Now calculate the value of X. So basically they want time, because they said X seconds after stone A was thrown. Okay, okay guys, so the way forward to this question is to do data for A and data for B. Okay, so for ball A we are given VI is equals to 10, né? And 10 meters per second. We also know now H max, maximum height, of which is equals to, I think, 45,1, if I'm not mistaken. Then okay, this is what we know. We also know G here, G of which is equals to negative 9,8, because I choose my upwards motion is positive. Okay, here V initial is equals to 0, G is equals to negative 9,8 meters per second, and we also know that the time here is a certain time, and then let's say time here is equals to t when they are equal, and time here when they are equal, t is equals to t minus x, because they say x seconds after, so x seconds must be subtracted. Okay. Oh. No. It must be added. So I'll call this one T1. This is T2. Okay. So yeah. Now with this information, we can see what we can do. So again, they meet at a common height where h is equals to 29.74 meters, and even here h is the same as 29.74 meters. Okay guys, so this is a simultaneous equation because we have two equations, the equation for data A, data B, and data A, stone A and stone B. Okay, now I'm going to erase the given information so that we start to solve it. Okay guys, so looking at this equation, we have our height where the two balls meet. We do have initial velocities for each case. We do have this. The variable we are looking for is time. So in the case of the first ball A, for not ball but stone, for stone A, the two balls meet at the point 29.74 meters, which is equals to the initial velocity for the first ball was 10, so we have 10 times time t because we don't know it, plus 1 over 2. Okay, this one we can call it t1 for now. 1 over 2 g. Okay, I'm sorry for this, but I'm substituting now. So plus 1 over 2 into the negative 9.8 into t squared. Forgive me for this error. This should be negative because at this point the ball is going downwards to the negative direction. Our initial direction was upwards as positive. Okay, now I'm going to transpose everything to the other side so that I have this as a positive number. Okay, so this divided by 2 is gonna be 4.90 squared minus 10 t1 minus 29.74, which is equals to 0. Using quadratic formula to solve for t, t1 is equals to 2.33, or t1 is equals to, so this will be negative 1.65. I hope this calculator gives me correct values. Okay guys, but we do know that time cannot be negative, so this value does not apply. We are only going to use this. Time is always positive, time is always ready. Okay, so for t1 we got 2.33. all right, now let us calculate again for stone B now. Okay, Okay, for stone B, the following. Remember, they meet on the same spot, meaning the same height. So the height for stone B is also negative 29,74, which is equals to initial. Ne? So stone B was dropped. So initial velocity will be 0 multiplied by t plus 1 over 2 into negative 9,8, then multiplied by t squared. Okay, so this is a negative number divided by this. So here we have negative 29,74 divided by half of that, it's minus 4,9, which is equals to t squared. So t is equals to the root of that. So we're gonna have the square root of 29. Oops, jeez, forgive me. The square root of 29,74 divided by 4,9. Square root of, okay, this is 4,9, this is 4,9, then the square root of, okay. Now we have 2,4,6 as our answer here. Okay guys, I want us to recognize this as T2, né? T2, because we are calculating for a different stone. Sorry for not rectifying it. Now if you want x is equals to T2 minus T1, which is equals to 2,46 minus 2,33. Okay, so 2 minus 2 will be 0, 6 minus 3 will be 3, 4 minus, so it's 1, 3 seconds. So that means the second ball was thrown 0,13 seconds later. Okay,